We're ready now to look at some basic trigonometric identities. And the way we're going to do this is to combine our concept of a unit circle, so our radius here is 1, and using triangles to determine our trig functions. So recall from our discussion on the unit circle that each point on the circle is represented by the coordinates cosine theta, comma sine theta. So we see that the adjacent side of our triangle is the cosine of theta, and the opposite side of our triangle is the sine of theta when we're dealing with a hypotenuse of 1. So a triangle that fits inside our unit circle. Now we can use Pythagorean's theorem for a right triangle to say that the hypotenuse squared is equal to the sum of the sides squared. Another way of saying that with our particular triangle is that cosine squared theta plus sine squared theta is equal to 1. This is a particularly important trigonometric identity that we will use in many applications. And we can automatically come up with a related identity by dividing every term here by cosine squared. So if we divide an entire equation by cosine squared, we will get 1 for the first term, sine squared over cosine squared for our second term, and 1 over cosine squared on the right-hand side. Now, typically this identity, or manipulation of our original identity, is written in terms of our other trig functions solving for 1 over cosine squared, which is identical to secant squared. So we typically write this as secant squared is equal to 1 plus tangent squared. We can find a similar identity by dividing our base trigonometric identity cosine squared theta plus sine squared theta equals 1 by sine squared and solving for 1 over sine squared, which is cosecant squared, to get cosecant squared theta plus equals 1 plus cotangent squared theta. Now how are we going to be using these identities? Let's start by using an example with cosine squared plus sine squared equals 1. So for our example, we will be given that cosine of theta is equal to minus 3 over 5, and that our theta is in the second quadrant. And we want to determine the sine of theta and the tangent of theta. So coming back to our unit circle, this is our first quadrant where I've drawn my triangle, and we move counterclockwise labeling our quadrants. So the second quadrant is over here in the top left. What we can notice about our second quadrant is our x values are now negative and our y values are positive. So that means that our sine of theta will still be positive, but the tangent of theta, which is the ratio of sine over cosine, will become negative. So now we can use our identity cosine squared plus sine squared equals 1 to solve for sine or sine squared. So I solve for sine squared theta is equal to 1 minus cosine squared theta, and I can substitute in our values for cosine of theta. Continuing to solve, I have 1 minus 9 over 25. Notice that this negative 3 becomes positive 9 because I'm squaring it. Writing it as a common denominator, I get 16 over 25. Now this is sine squared. So I need to take the square root of this in order to determine my answer. And I'm going to note that the square root will give me two choices, plus 4/5 and minus 4/5. But since we know our quadrant, sine of theta is greater than 0, we pick that sine of theta is equal to 4/5. And now that we know sine and cosine, we can create the ratio tangent theta is equal to minus 4/3.